This outer circumference right here, that's the cortex. Cortex. This inner part right here is the medulla. The medulla, right in here. This is all medulla. This is cortex out here. Okay? Cortex, medulla. All right? And let's just take them in alphabetical order. So I've shown you the cortex and medulla. The renal pelvis is right here. Now I know when you think pelvis, you think pelvic girdle probably because of the bones that we covered in 1217. The renal pelvis is right in the pelvic area, so that's what we refer to as renal pelvis. This is, will go into the ureter, which is right here. This is the ureter, okay? All right? And what we have up here is, you can see right here in red, and right there in red, Shane, what vessel is this? It's labeled number 14 there. You know, Shane?
The renal artery.
Perfect. And Alyssa, when it comes in, it splits right here. That vessel right there is what then, Alyssa? Exactly, that's the segmental artery, perfect. And as we come up through here, Jessica, that's going to be what vessel? All right, Brian, do you know?
Interlobar.
Exactly, interlobar. And then Hannah Sandstrom, when we get up here and it's starting to curve like this, that is the
arcuate.
Perfect. Perfect. Arcuate artery. And then Shanna, out here, the red one's right out here.
The cortical radiate arteries.
Perfect. Perfect. All right. So those are the cortical radiate arteries, and then you also have the veins. So you've got the cortical radiate vein in blue, arcuate vein in blue, interlobar vein here, and renal vein down here. Okay? They parallel one another. All right. Okay. Then each one of these triangular structures right here, that's in the medulla. This is called a renal pyramid. Okay. It has kind of a pyramidal shape to it, like here. All right. Renal pyramid. Within that, you've got all sorts of collecting ducts that run through here. Okay. Now, what I'm going to do is this, and the loops of Henle are also there. This shows that right here. You see this is a collecting duct in the middle of these loop of Henle's. I don't know if any of you ever played a trombone, like in a band or something, but it's got kind of that, how do I call it, a sieve? I forget. The moving part of the trombone. You made trombone players? You just play trombone, all right? But it looks kind of like that. Now, if we take this area and blow it up, okay, blow this up, it's going to look like this, okay? This is the second part of the kitty model. This is the cortex out here, the medulla here, all right? Now, let me go back to this, and Sarah Hill. Sarah, this is the cortical radiate artery right here, okay, right there. You see how there's a branch that comes off here, Sarah? That branch that comes off right there, that is the what, do you know? Perfect, all right? And then Kaylee, where it's kind of bound up right in here like this, like a ball of yarn, that red, you know what that is right there?
I don't know.
Okay, Amanda, do you know?
Is it this one?
Exactly, that's the glomerular capillary. Glomerular capillary. Now, so Beth, this glomerular capillary will have a blood vessel that leaves out from it, and the one that leaves out from it right here, that's the what? Do you know, Beth? That is perfect. It's the efferent arteriole. And then let's move this over this way. And I'm going to take one of these. Now, this C-shaped structure, that's the glomerular capsule, Bowman's capsule. All right. I'm going to take one of these right here, and we're going to blow that up big time. Okay? And this is what it looks like if we blow it up big time. All right? Now, this blood vessel right here is the afferent arteriole, right at the tip of my finger. All right? And then it comes in here, and Matt, do you know what these are right here? Those are actually going to be the glomerular capillaries. Okay? The peritubular are going to be outside, but that's close. But that's the glomerular capillary. And then, Skylar, do you know what this vessel is here? Tip of my finger. Because it comes in afferent, glomerular capillary, and then it's going to leave. Okay, Chris?
The afferent arteriole.
Well, how'd you spell that? So, what are we going with, Chris?
What?
Yeah, which one are you going with?
The
efferent arteriole. What, that's with E?
yeah.
Yes, that's correct. Okay? That's why spelling counts. Because there's a one difference, right? Letter difference between afferent and efferent. Okay? All right? And that's the efferent arteriole. Now, this structure right here, right there, Christina, do you know what this is right here in green? Right here? Exactly. That's the glomerular capsule. Perfect. Either one's fine. Yep, either one's fine. And then what's this coming down through here? Glomerular capsule leads into Taylor. We've left the blood. Perfect. That is the PCT right there. Exactly, Hope, you got it? All right, so that's the PCT right there, all right? Okay? Now, going back to the sheet, the lab study guide. I showed you the pyramids. Let me go to the KLCs, okay? And what we'll do on the test, I'm just trying to be upfront with you. We're gonna take pieces of tape on it. If I put a piece of tape right here, say name the structure, that would be the minor calyx. See that its collecting ducts dump down. Think like a plumber. Dumps down right here, right there. Okay? All right? Minor calyx, when you add two minors and put them together, you end up with a major calyx. Okay? So minor calyx, major calyx, into the renal pelvis here. Okay? All right? Now, the nephron. Okay, I did, let's do this, yeah, here we go. Switch back over here. Okay, and Taylor, let me come back to you here. This right here is a glomerular Bowman's capsule right here, all right? And then do you know what would be this white tube right here, Taylor? Perfect. The PCT, you're right. And then right here, it's Kayla, I'm sorry, Kayla. Do you know what this is right here, Kayla? Coming down like that. Perfect, Kayla. Okay, descending loop of Henle. Annie, what do we got coming in this way?
The ascending loop of Henle.
Perfect. And then Christina.
Yep.
Got it. Christina, do you know what this is right here?
Is it the distal tube?
Yeah, exactly. The distal convoluted tubule. Perfect. DCT. You got it. And then is it Brandon, right?
It's Kevin.
Kevin. Kevin, do you know what this is right here, Kevin?
I'm not sure. I'm guessing the collecting ducts.
Perfect. Collecting duct. All right.
Duct.
Collecting duct. Right through here. All right. Now, let me do one last thing here on that renal corpuscle. Okay. This is a renal corpuscle right over here. Okay. All right. And the renal corpuscle consists of the Bowman's capsule or glomerular capsule. You can use either term, doesn't matter. There's a visceral layer and a parietal layer out here. Visceral, parietal. Okay? And then you got the proximal convoluted tubule right here. Now, two things I want you to notice here. Let me ask this question of Equa. Equa, you ever made spaghetti noodles? Cooked them up. Okay? You have the strainer at home? Send it to the strainer, right? How could you get, if you wanted to, how could you get spaghetti noodles through the strainer?
You're small enough?
Oh, okay. Good answer. That's tricky. Threw me for a loop there. But how about if it was regular sized noodles? How could you get them through the strainer? No idea.
They don't come out.
Oh, but you could get them out. You don't get that, Shane?
I don't know.
Listen, have any idea? Let's put some pressure on the noodles, right? Now, I've never done this, but if you had the strainer there right with the noodles, if you put your hand on top of the strainer and pushed on the noodles, right? Couldn't you extrude them through this filtration slits, right? I mean, you just push them through, all right? Now, the only reason I bring this up is this, right? Now, if it opens it up more, Hannah, then what's more likely to come into my urine that shouldn't be there? Blood, red blood cells, right? Now, if you urinate red, you've got a problem. okay? You know, there's only been about, there's been 2 dozen times in my life when I've urinated pinkish red. And each time it's after I ate a bunch of beets, okay? Literally, if you eat a bunch of beets, your urine will turn pinkish red and it'll scare the daylights out of you, okay? Because it did me on halfway to the ER and thinking I was dying. You know, you just ate plated beets. I really like beets. And if you overeat beets, you will urinate pink. But if I ask you this, assuming you're not beet eaters like I am, I just tend to overdo it because of my obsessive compulsive beet behavior. If you don't eat a lot of beets, you should never have had red urine. I mean, to this point in your life, if you had, I don't know, just raise your hands, but you should not have urinated red to this point in your life. It should not have happened. And it shouldn't happen, okay? And what happens is, if you put too much pressure, these will open up. Hypertension does irreversible damage to kidneys if it's not controlled. Okay, that's a lot of times why people end up on dialysis is usually they're diabetic and they have hypertension. Okay, or they have hypertension and they're not controlling it. That's oftentimes why. I know there's some other reasons why too, but those are some of the major reasons why. Why do people end up on dialysis? Okay, why is that? And one is sometimes they don't have their hypertension under control. Okay. Now, last thing, okay, and I went through that stuff there. The last thing I want to show you here before I give you your assignment is this. On this handout, it talks about a histology slide, okay? And if you remember the last lab test, we had like a selection of the lungs. I forget, there was a neuron or something on that last lab test and so forth. And I just want to show you, this is being able to identify these things. And let me just show you, I've got on D2L, on the course website, I have a biology 1218 histology video.